Hey, I'm Bob and I like to make stuff. Today we're going to start making R2-D2. This is a project that I've been wanting to do for a very, very long time. In fact, since I was a kid, I've always loved Star Wars and I've always wanted to have an R2. So I decided recently to get started on the project, and the first step was a ton of research. The R2 Builders Club has a website called astromech.net, and this is the place you're going to go for all of the information that you're going to need. It's a community of people that are super helpful and willing to answer questions, plus there's blueprints and tons of reference for everything. So as you're doing research there's a bunch of decisions you're going to have to make before you can even start. And those decisions are things like what material you're going to use, what functionality it's going to have, whether it's going to lean back, have 2 legs, 3 legs. There's a ton of options. I haven't decided on all the functionality I'm going to use yet, but I did decide to make the core, or the frame, out of plastic. I'm going to use something called styrene, which is an ABS plastic, so that I can cut it on the CNC. If you don't have a CNC, you can certainly just go onto the website and print out templates that you can glue onto plywood or plastic. Those things can be cut out with normal woodworking tools, or you can just use a hobby knife and a chisel. Either way, you're going to have some files handy so that you can get a really nice fit on all the different pieces. Another option is 3D printing. In fact, you could 3D print top to bottom the entire droid if you really wanted to. You could certainly make every single part on the droid yourself if you want to, but there are also vendors who create screen accurate parts, and they sell them in batches. If you keep an eye on the website, you'll see when a vendor has a new batch of parts, and you just put your name on a list so that you can get the parts that you need. But the downside of that is that you have to kind of wait in line, and you have to wait for the parts to be available. The upside to it is that you get beautifully machined aluminum parts that are super accurate. I decided to make the inside of the droid, but buy a lot of the outside pieces from these vendors. I got the skins and the dome, and then a whole bunch of these detail pieces to fit in, and they are beautiful. These are ready to go for paint or powder coat. So I have my first cuts of R2-D2 finished on the CNC, so it's really cool to have the frame all ready to go and start assembling it. Obviously, if you don't have a CNC, there are other ways to get that cut. Most people will go to a local office supply store, like I did. I spent about $18, printed out the templates full size, and then they glue these onto the material and cut it out with a Dremel or with a jigsaw or something else like that. The irony is, though, that I actually had to go get these things printed out anyway, even though the pieces were cut on the CNC. When I went to start looking at assembling the frame, I realized that a lot of the marks on these templates are really about placement and assembly, not about cutting. So I had to print these out. I'm going to have to cut these out by hand and then glue them onto the frame before I can start assembling it. Now luckily I don't have to cut everything out. These have all been cut and they don't really have any special information on them. The big thing is these rings. These dark areas are where you put the uprights, and so I have to cut these pieces out, glue them to my plastic, and then score over these lines, then take these templates off so I know where to put the uprights and glue those things in place. So I'm going to start going through these sheets and cutting all the pieces I need. There were some pieces that I had to bevel using the table saw, but you could also do that with a file if you need to. That's so that these pieces will fit together at the right angles. And to hold them perpendicular to each other while I glued them up, I used these 1, 2, 3 blocks. These are great for keeping things parallel or perpendicular. To assemble all of these plastic parts, I used CA glue. There are special solvents that you can use for all different plastics, but I did quite a few tests, and the CA glue actually seemed to work out just fine and be strong enough. Luckily, the construction of this frame lends itself to being pretty strong, and so the individual joints don't have to carry a whole lot of load. One of the parts that I ordered were aluminum skins. These are the actual body panels that go on the outside of the droid, and these turned out beautifully. These are laser cut aluminum and then rolled on a machine to the right radius, and they look great. Even after making the frame, you do have to line up some of the individual pieces with the openings in the skins. There's all these panels in the skins that get cut out, so you have to make sure that the frame behind those openings is clear. Something I'm not used to about this R2 project is that a lot of the pieces are actually better to be made by other people. They'll do parts runs where they'll take orders for a certain part, then they'll make a whole bunch of them, and it's usually the machined aluminum stuff. These are some of the ones that I just ordered, and I haven't looked at them yet, but they look so good. It's totally worthwhile to get something like this done. I mean, you could 3D print it, I suppose, but like, there's a contour, it's super well machined, it's just ready to drop in and ready to go. So for example, on these, the back surface here needs to stay aluminum, and this needs to stay aluminum. So they're made so that you can unbolt this, pull the whole back off, and then paint the inside here, and then bolt that back on. Works out pretty well. Now they are usually more expensive, but this project is not really a cheap project anyway. I followed the same process for cutting out the templates and cutting out the pieces on the CNC for the legs, and then it was time to put them together. The body of R2-D2 was made all out of one thickness of material, and I've used that same thickness to cut parts of the legs, but the legs actually do require 2 other thicknesses as well. I've put those on order, and while I'm waiting for them to show up, I'm going to go ahead and assemble these pieces that I have so far. Luckily, the instructions that the guy put out with these files are super easy to follow. It's just a matter of gluing this stuff together just like I did the body. And actually, these legs are far from complete. There are tons of detail pieces that get put on the outside, plus the ankles and the actual feet. But after several weeks of work, I was dying to actually see if it looked like R2-D2. So I decided to loosely bolt the legs together, tape on the skins, and then drop on the dough. Obviously, I am super excited about this project, and it is really cool to see R2 up to this point. Now, this is a very long-term and a pretty expensive project, and I'm not going to go over the specific costs that I'm putting into it because it's going to be different for every person. Depending on what build type you're using, what materials, your cost is going to be very, very different. Because it's such a long-term project, I don't know when the next build video is going to be out about R2, but if you don't want to miss it, be sure to subscribe. And in the meantime, I've got tons of other project videos of all different types that you can check out right over there. That's it for this one, guys. Thanks for watching. See you next time. I'm really happy to have gotten this far so far. That's my out of order. Tons of other project videos for you to check out, so click out. Hey, I'm Bob and I like to make stuff. Today we're going to keep working on R2-D2. We're finally back to working on R2-D2. And if you didn't see part 1 of this build, go check it out. It explains how we got to this point right here. But basically, let me bring you up to speed. We've got the aluminum dome that I did some work on to cut out the panels. We've got the aluminum skins, which I also cut out panels on. And last time we built the internal frame, and this is out of styrene. We also have the legs built out of styrene, but we don't have any ankles. So this thing can't sit on the ground yet. So one of the goals for this video is to get the ankles built, to get all of the features on, to get them painted, and basically complete but static. I would be really happy if I can get R2-D2 to look like R2-D2 even if he doesn't do anything yet. We'll get to the electronics and the lights later on. I ordered a bunch more of the detail parts that are machined aluminum. I'm waiting on those to come in, but all the parts that aren't going to end up being aluminum finished, I'm going to go ahead and 3D print so that I can save on weight and on cost. And the first one of those is the skirt that goes on the bottom of R2. Let's start on that one. Like I mentioned in part 1, astromech.net is the forum where you get all the information you need to build an R2 unit. In fact, they also have a bunch of 3D files that you can use to 3D print parts. Not everything is there, but I did find the skirt, and so I printed out all the different parts in black. I'm going to glue these pieces up and then finish them and paint them white. The next real piece to put together here is the center ankle, and this goes inside that skirt. Now this was made of a bunch of individual pieces, just like the frame was in part 1 of this. I glued all these up into a single block, and then I ran it over the belt sander to get the edges kind of smooth, but you can still see the individual pieces. So next up, I'm going to add some Bondo to try to make this look like a solid piece. I continue to work on this center ankle. I've got it pretty much cleaned up on the outside, and then I started to add these pieces on the sides that are detail, and this is a thin material to build it up and give it the curve. I bought some of these really nice machined aluminum pieces that go on here, and when I set them in place, I realized that the angles don't match. Now this is one of those cases where I thought I was following the instructions correctly and I was kind of afraid to adjust it, but now I've got the confidence to realize that I'm just gonna have to tear this out and remake it to fit these pieces. It was actually kind of freeing to tear it out and make the correct piece so that it fits together perfectly. So I'm learning as I go here that I can't always follow the instructions exactly. Sometimes you just gotta go off script and make it fit. Over the past few days, I've been doing a few different things. One, I separated all the pieces that I have so far into the different colors. So some of these are gonna stay silver, some of them are gonna be blue, some of them are gonna be white. So I started kind of breaking down those, and that also helped me figure out what pieces I was still missing. We've got a couple more things on order, but then on top of those, I've actually been working on the skins as well. This is the more exciting part to me, because these skins are actually attached to the frame now. These are the inside skins, the bottom skins, and then there's outer skins that go on top of those, and that's what I want to work on now. These inner skins are screwed on. I put in some little styrene blocks and then drilled and countersunk some holes right there so I could put in small screws to hold these on. That way if I ever need to take them off or anything, they're not glued in place. The other skins that get painted white are going to go on top of these and be attached in the same way. They're going to get a couple of small screws right in that same kind of area to hold them in. The leg goes right here, and so the leg will cover up any of those screws that you can still see. With this outer skin on, you can start to see the kind of two levels that you'll notice on R2-D2. This inner skin stays silver, and then this outer skin will be white, so you'll start to get a lot of dimension on all these panels. Then there's white panels that get glued on top of this that will cover up the opening. I'm making some marks on the outer skins to show me where the screws on the inner skins are so that I don't accidentally drill in the wrong place. And then before I drill the holes to attach these skins, I want to put the legs in place to make sure that they fit within this opening, because that's pretty important. I know that the legs fit in the openings now, so next I got to take them back off and then attach the outer skins by drilling and countersinking some more holes. I'm ready to move on to painting some of the panels. I'm just going to do the ones that aren't going to be attached yet, just so I can figure out the paint process. So this is bare aluminum, two pieces glued together. And to paint this, I'm going to use some aluminum primer. Some other people use a self-etching primer instead, but I think both will give basically the same effect. I'm going to lay down a coat of this, then come back with a normal gray primer on top of that, sand that really smooth, and then hit it with some matte white. Now this is the color that everybody seems to use for the actual body finish. I'll use a different color for all the blue parts, obviously, and that's a certain mixture that we'll have to figure out later on. For the past several days I've been painting on and off and putting primer on the pieces and final paint. These are two pieces that are completely done and ready to go. These have the satin white finish on top of them and they look great. So this is what all the pieces that are white will end up looking like. I've also been working on the hubs. Originally these were white on the outside. They were covered with really thin styrene, but I realized that that was actually wrong. These needed to be aluminum too. So what I did was cut down a little strip of aluminum flashing and glue it around the outside of this with some E6000. It's a really great adhesive that attaches all sorts of stuff to all sorts of other stuff. I also used rubber bands as a clamp when I was gluing that up because it adds an even pressure on all sides of the circle. So this will eventually be stuck on the inside of the leg and go in between here and the body. So the next thing we're going to do is start to attach some of the skins. I've got the outer skin that's painted white and the inner skin that's aluminum, and so we've got to glue these two things together to be one piece. I've been painting and painting and painting all of these different parts, both white and blue, and I'm down to the last few blue pieces, and I wanted to point this out because I've had to mask a lot of these. And this one in particular, you only have to paint the top of this ring blue, so I've masked all the area around it, but then there's also this cup area in here, and I need to mask that as well. To do that, I'm gonna use hot glue. I'm just going to put a screw in there so when it dries and I'm done painting, I can easily just use that to pull it out. Now I'm ready to put on the back door, but I want to make sure that this thing can come on and off so I can access all the electronics on the inside. The idea was to mount that plate, that body panel, to this door, which was made to fit in here, but once I have these skins on, this actually won't quite go in. I don't think it's really necessary, so for now, I'm going to leave this out and just make it so that this panel can lock into place and probably stay there with some magnets. I'll end up adding those magnets later on, but for now, I just wanted to make sure that it actually fits in place and sits flush on all the sides. When I ordered the dome, I also ordered a bearing for it to turn on, and this actually is from Rockler. But the bearing and the dome are made to go together so that the holes line up. I've put these posts in here, and now I'm going to mount this outside ring temporarily down to the frame just using some screws. There we are. It's starting to look like R2-D2. I'm honestly not really sure how to break these videos up because there's no real clear part 1, part 2. It looks different than it did before, so we're going to stop right here. On the next part, we're going to do a bunch of different things, probably finish up the legs and get them mounted on, maybe start working on the dome and getting it ready to be put into place in its final form. Like part 1 to part 2, I have no idea when I will get part 3 out. These things take a long time, there's a whole bunch of little tasks, and I'm working on this outside of everything else that we're doing. So be patient, we'll definitely get a third part out to you as soon as we possibly can. I'd love to know if you have any thoughts on R2, if this has inspired you to take on a project for yourself. I'd love to hear about it down in the comments. We've also got tons of other types of project videos that you may want to check out, and if you're not subscribed, do that as well. That's it for this one. Thanks for watching. See you next time. You need to go check it out because I need to slow down. I'm ready to move on to painting some of the panels, just the ones that aren't ready to get that aren't up to High five, R2. Thanks, R2. Hey, I'm Bob and I like to make stuff. Today, we're gonna keep working on R2-D2. And we're back working on R2-D2. Last time we got a lot of stuff done on the skins. We got them all painted white. A lot of the other pieces are painted white and most of the pieces were painted blue. After I finished that video, I actually had some trouble with the blue and I wanted to talk about it. This is one of the pieces that I painted last time. This was the blue coat with a clear coat matte on top of it, and it looks great, but it actually didn't hold up very well. Once I started touching some of these edges to other pieces of metal just by accident and brushing them around, it started to chip a little bit. I did a little bit of research and found a better way to paint them, but it does change the color a little bit. On our podcast, I asked for some ideas about how we could get this paint to thicken up a little bit and not chip off, even with a clear coat. And somebody turned me on to this catalyzed spray. This is a 2-part mixture in a single can. It works for about 48 hours before it hardens up. But when you spray it on top of paint, it adds a really hard clear coat. And based on this, you can see that it also changes the color just a little bit. But these pieces that I've already painted with the catalyzed stuff are holding up a lot better. The other day I started working on the legs a little bit more. I 3D printed this booster cover. This is in 3 sections. I glued it together and finished it just like I finished all the other pieces in the past videos. But I sprayed this one blue. It does not have the catalyzed clear coat on it yet. I'm gonna make sure that I get all the blue pieces painted and then use the catalyzed spray on them, because once you mix this up, you've got 48 hours before it goes bad. So now that I've got this piece done, I can start kind of laying out where all the pieces on the outside of the leg go. So I'm just kind of mocking up where all these pieces are supposed to go. Obviously I'd have to drill and screw everything together. These white shoulders still have the masking tape in here. This will all be exposed aluminum, but I haven't put the clear coat on these pieces either, so I'm keeping those covered for now. I've got all these pieces kind of roughly in place where they're going to go, and it's starting to look really cool, but I can't attach anything until everything is fully painted. I can't paint everything until I finish the ankle. I'm not going to do that right now. In the meantime, I'm going to work on the dome. The dome is made out of 2 pieces, and I've shown you this before. These fit over each other, and then you just have to line up the pieces and they get glued together. But before they get glued together, I want to go back and polish all the surfaces, especially the inside surface, because it's going to be harder to get to, obviously, once the top is glued onto it. I've been working on the legs a little bit, and this one is just about ready to start putting on primer and paint. But before I did that, I wanted to point out something. One of the cool things about the R2-D2 build is that it can be a hybrid. So I've got some aluminum pieces that I've purchased from other people. I've got styrene parts for this build, and I ended up 3D printing this piece just because it was a lot easier to get that shape correct with a 3D print rather than building it out of styrene for me personally. But the cool thing is that it's all built off the same spec, so you can get this file from one person, this file from a different person, and they're still going to meet up and line up just fine. So I got this one on, got it glued in place, and then just had to fill the seam. But other than that, it's good for a little bit of sanding and then primer and paint. Last time I had most of the pieces painted blue, but after I started installing some of them and handling them, the blue started to flake off, and it's a very thin paint. Part of the reason I think was the primer that I used, so I actually stripped both of these down with a sandblasting cabinet. Then I used a self-etching primer on this. I still have to spray the bottom, but I want to try that as a base for the blue and see if that works better. On this one, I actually need to paint this one blue again, but last time I did it, I put in kind of a mask down in this channel because that channel does not need to be blue. It needs to be aluminum. That mask didn't really work super well, so this time I'm going to use Silly Putty. From the last batch of blue pieces that did get painted and are in good shape, a lot of them are ready to be put on the dome. The ones that are going to move, I'm not going to mess with yet, but there's a bunch of these that are just fixed. And so these are just going to get glued in place, and then I'll put some tape to hold them to make sure that the margin around it is the same while that glue sets up. This glue holds really well, but is also removable if you need it to be. So I'm not going to completely cover it. I'm just going to add a few dots so it'll stay in place. As I'm moving along on the dome, one of the next steps is to put in these beautiful hollow projector eyes. These were things that I bought from a guy that machines them, and they're really, really nice. They come with servo mounts on the back so that you can control them and turn them once they're in the head. But now I need to mount these inside the dome, and when I went to put them in place, I realized that actually some of the holes are too small for these lights, which is kind of a drag. The hole here is the right size, but the panel that goes on top of it is actually too small. It won't lay flat. So I've started filing that out to make it the right size, and of course that messed up the paint, so I'll have to repaint these. One of the bigger problems though is that I actually did this out of order. These pieces should be attached on the inside of the inner dome, and you're supposed to use this inner dome to be able to drive screws through, and then when you put the outer dome on it, you hide those screws. Well, unfortunately I already glued these together, and this is the only one of the three that I can still get to and put in those holes. So I'm gonna have to come up with another solution for mounting these things. I just got the first of the 3 hollow projectors installed, and this is the one that I actually put through the inner dome, so I just followed the instructions that came with it. This is the way most people put them in, drilled some holes and mounted them, and now this whole piece can move, which will eventually be controlled by some servos, but for the other 2, I can't screw them in like I did that one, so I'm gonna have to come up with a different way. I tested this one out and I think it's gonna work fine, so I'm gonna do the other one the same way, but basically I'm gluing it in place instead of bolting it through, and I'm using the E6000 glue, which I've used a bunch of different times, and it works great for aluminum to aluminum connections. I'm only really gluing in that retaining ring that's on the back side. In fact, this is the wrong cup that goes here. It's the same size, but it's not the right one. So I'm gonna push this back so it's not gonna get glued in place, and it's actually gonna be stuck to the back side of that tape. So after this glue dries, I can take off the tape and this cup should come right out. Now that I've got all these hollow projectors in, I just need to hook up the servos so that they'll move, but in the meantime, I also have the lights to put in. Now this is a kit called the TC's kit that I ordered online. You can buy all these individual pieces, solder this up yourself, but getting a kit saved me a huge amount of time. And honestly, I just plugged in these wires, plugged in some batteries, and you turn it on and you're good to go. One of the things I didn't realize when I was ordering this is that on the back of these, there are terminals where you can plug in another single LED, and these are actually made to go inside the hollow projectors that I just installed. So I kind of got a 2-for-1. And to make these LEDs fit in there, I took one that was a little bit oversized and actually sanded it down on the belt sander to make a profile that will fit in the back of the hollow projector. We're finally at a place where we can start putting together one of the legs. Now what I'm talking about here is this section of the leg, not the ankle. I haven't made any of that stuff, but I've got pretty much everything from here up that I can assemble and attach to the body. Let's do it. Gonna have to cut down a few of these so that I have room to turn the nut once I get it on top of the bolt. I've got the legs almost finished and I'm really anxious to put them on the body, but before I do that, I have to run some wiring. This hub goes down inside here, but that actually covers up where the wire needs to go through. So before I put that in place or the leg in place, I'm gonna run some wire through there, down the channel, inside the leg, and have it come out the foot. That way, when I get to building the feet and adding the motors, I'll have a wire down there ready. I've got the light pack ready to go in the dome, and it came with a few pieces that I've already installed, some diffuser plates, but it also comes with some pieces of PVC which act as little tunnels, and then the lights get mounted on the end of them. I'm going to glue these in place, but I also wanted to show you these different matrices that got glued in, and then the LEDs plug into the back of those little matrices. Now that I've got those glued in, I can put these into those holes and just use some hot glue to hold it together in case I ever need to take it out. He's got an eye, he's got some lights. This is a good place to stop this particular video, but there's gonna be a lot more to come. In the next video, I definitely wanna work on the feet, try to get him rolling around a little bit, and get a motor in the dome so his head can spin. Plus, we've got panels to put on hinges. We have a ton of work to do on R2-D2. If you haven't seen the previous R2-D2 videos, we're gonna have a playlist with all of those that you can go check out, but we've also got tons of other types of project videos that you may wanna see as well. If you're not subscribed to the channel, be sure to do that so you can keep updated with this guy and with all the other stuff we've got coming. That's it for this one. Thanks for watching. We'll see you next time. We've also got tons of other types of projects that you may want to check out and 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 check out. With all those listed, you can go watch them whenever you want to. You can go, yeah. Bleep bloop. Check all those out if you want to. Hey, I'm Bob and I like to make stuff. Today we're gonna make R2's head spin. Hey everybody, welcome back to part 4 of the R2-D2 build. I want to give you a quick run around of where he's at in case you haven't watched the previous 3 videos. This is an R2-D2 built in a styrene plastic frame. He's got aluminum skins glued to the outside. Then these legs are made out of some stacked styrene plus some 3D printed pieces and some machined aluminum pieces. The legs are in place. They have wires going down to the feet so that we can hook up motors. I've also worked on getting all the paint on. I've got all of the pieces that are going to be blue painted. I've got most of the pieces that are going to be white painted. And also in the last video, we got the dome really far along. I've got some lights in it now. I've got most of these panels put on. We just have to put in the panels on the top. With the lights in place, we've got some LEDs run to all the different holo projectors and everything. So this is now ready to be put in place and motorized. One of the big things that I want to do is to get the head to spin. I cut out this gear on the CNC. This is out of styrene. We also made some little motor mounts, and these were all files that I found online for free. So we've got this motor mount mounted onto this motor, which is offset. It's kind of weird, but this is made specifically so that you can put on a little piece here and then put on a gear right on top of that. Then this will get mounted inside, and as this gear spins, it will spin this. This will be attached to a Lazy Susan, and that should make the whole head spin. Just to make sure everything's working, I've got this hooked up to a power supply. This thing needs 12 volts, so I've got that set here, and if I turn it on, it should spin. I've got it temporarily clamped in place, and I'm just gonna make sure that everything turns smoothly and everything before I actually bolt all that motor mount and all that stuff into place. Even though there's a whole lot more to do before this is actually in place, I can't help but put the actual dome on here and just watch it spin. Let's do that. That's super cool though. Now that the dome is spinning, we're going to move on to this giant hole in the back of R2. Now this is supposed to be an access panel. There's a whole body panel that is supposed to go on there, which should be mounted to a door, which was made to fit in that opening. Unfortunately, once I got the skins on, the door doesn't quite fit in there anymore, and having it come in and out would be really difficult. So I'm going to take some scrap styrene and build out this shape a little bit, closing it in, and then make a new door that fits in that space, then attach this panel to that new door so it can come on and off. we've got the new door. I made this up yesterday, and it's basically the same construction as the entire frame, all the stuff you've seen me do before, but I cut down these pieces, put in a new top plate, some new sides, and then this new door that slides in there. It's kind of tight, but it does fit all the way in, and that's important. So next, we're gonna take this big back panel of the skins, which is all made up, and this is gonna get glued in place onto that removable section so that when the entire thing comes off, it will take this with it. These will be glued together. Now, one of the problems here that I found when testing this out was that by putting on these outer skins first, I've ended up with some gaps. Up here at the top, it actually looks just fine. We've got about the normal size gap all the way around, but then down here on the bottom, the pieces kind of spread out. So you get more gap over here and then more on the other side. Unfortunately, there's not really anything I can do about that at this point, so I'm gonna have to just make this door up and then put in some filler pieces on the inside of the body to cover that gap. The glue is dried on this back panel, and so now R2 has a door that comes off and it takes the structure with it. This is really cool and it fits really nicely, but there are those gaps that I mentioned earlier down here and on this side. So what I've done is cut down some more pieces of the white styrene. I'm gonna take off this door and glue them right in here up against that edge to kind of fill the gap, and then I can even go back and paint this edge to make it look like it's aluminum, just to make it fade away even more. These pieces are also going to serve another purpose. They will be a place that I can put a mount for a magnet on this face, and then that will hold that back panel door in place all the way up against it so there's no gap in this direction. Now that I've got these panels in, the plan to get this whole back section to stick on is to take one of these rare earth magnets, screw it into that face right there, and then take this piece of steel angle iron and glue it to the back of the door. Now you can see that they really grab, which is good. The door will get pushed in and locked onto that magnet. So first, I'm going to start by screwing the magnets into this piece of plastic. The JB Weld has set up on all these different points on the back of the door, and it actually works out really well. Check this out. It holds in place, but once you snap it loose, you can get the whole thing out. These things also act as guides to help get it into the right position, which is pretty cool. Once you get it in there, the magnets kind of take over and snap it into place. For the past several weeks, I've been working on the hinges on R2-D2, and it's been surprisingly difficult to get all these hinges for these panels in the right place so that they can clear the body as they open and close. Because all of these hinges have to work on a curved surface, the hinge geometry is kind of interesting, and unfortunately I had to cut out a lot of the interior structure to make room for the hinges to go. So now I have to go back and trim all these pieces up so that they will fit around the hinges and put them back inside. And then I also have to go back and add a servo and a mount to each one of these doors so that the electronic system can open and close them remotely. And then I also have to go back and build a back panel in each one of these cavities so that you can't see straight through them when one of the doors is open. But for now, these hinges are done, so I'm going to move on to the hinges on the dome. The hinges for the dome panels are an entirely different beast because they actually need to work on a compound curve. This is in a dome, so it's got curves going in pretty much every direction. And I've been working for a long time now trying to get hinges mounted on the inside of this so that these panels can clear the opening when they flip out. I've had a huge amount of trouble with this, and I went onto the forums and asked some really helpful people about it. They've also had a lot of trouble with these hinges and offered up some suggestions to make it work. This is the hinge that I had been trying to use, and other people have used it successfully, often by modifying it, but the big problem for me was the amount of slop in this joint right here. It doesn't look like a whole lot when I move it, but that amount of movement makes it so that the panel can't sit correctly and can't clear the opening when you flip it out. The alternative that a lot of people suggested on the forums was a 3D printed hinge. And this is one that was modeled specifically to be able to clear the kind of weird opening of the dome. This was printed in 2 separate parts. It goes together with a bolt, and it has a built-in mount for the servo to activate the arm. The files also come with a little jig. You can print this out and use this to make sure that the hinge is put in the right place. I did a test print of one of these, put it in place with some hot glue to make sure it would work, and it worked perfectly the first time. So I ended up printing out 4 more, and I've gone ahead and assembled one of them, put on the servo, and put in a little arm so that the servo can control the hinge. Now I've just got to glue these in place, and the dome will look 100% finished. The dome is finally looking finished, really, on the outside. On the inside, it's got servos in place on the panels. It's got lights that actually work, but those things don't talk to each other, and they don't talk to anything else because he doesn't have a brain yet. I finally started working on the electronics to go inside of R2-D2, and I'm using a whole system that's been put together by the people on the Astromech forums. I'm going to continue to work on this, try to get it figured out, and get it in place. This entire system is going to be powered from one power source, and you can do that in a lot of different ways, but something I thought was really cool that a lot of people do on the forums is they use a battery system that they already have. I've already got a bunch of DeWalt tools, so I want to use these 20-volt batteries, and I actually found a simple adapter that lets you use these batteries in other tools. But the important thing about this adapter is that it lets you hook in right here. Then you have 2 terminals that you can tie into to actually connect the power to your system. So I just need to modify this thing a little bit so that I can put these wires on those terminals. With a little bit of soldering and some hot glue, now I've got an adapter that I can mount on the inside of R2-D2, and then when I want to actually power him up, I can just take the batteries, drop them in, and then close up the whole thing. After he runs out of battery power, I can take it out, swap it out with another one, and since I have tons of these batteries and chargers, I can always have a lot of power to take with me anytime I take R2 anywhere. Once I got the battery adapter in place, I finally got power to the electronics that I was working on and was able to really flesh them out. I don't have them all done, but I definitely have a working prototype taking advantage of a piece of software called Shadow. This is a whole system that somebody put together on the forums, which includes an Arduino sketch that will help you control motors and sounds and a bunch of other stuff. Let me show you how I've got it laid out really quickly. There's a lot here and it looks crazy because the wiring is temporary, but let me walk you through it really quickly. The 20-volt battery goes to a switch so you can turn the whole system on. That goes to a power block, which sends that power out to the motor controller for the feet. It also sends it to a converter which knocks it down to 12 volts, and then we've got a block for 12 volts here as well. That goes into another converter that takes it down to 5. So we've got 3 different voltages here that we can tie into. The 12 volt is feeding the Arduino that has a shield and a Bluetooth controller on it. It's also feeding a sound board. The output of that board is going into an amplifier, which is powered by 12 volts, and then connected to 2 speakers. The 12 volt is also controlling this head motor controller, and this controls the spinning of the dome. And all of that is connected through Bluetooth to this PlayStation 3 Move navigation controller. The code for this whole system is already written. You can modify little pieces if you need to. But once you connect this controller through Bluetooth to the Arduino, everything just kind of works. You've got controls here for a bunch of different sounds. You can spin the motors using these controls. You can use the driving control up here to spin the feet motors. And And this is a great place to start, and I've made a huge amount of progress. This is a huge step forward, and with what I have right now, I could actually put it inside R2 and it would roll around and make sounds and be awesome. But of course, there's still a bunch of other functionality that's not attached here yet. I haven't wired up the lights in the dome. I haven't wired up any of the servos for the panels to open, so that's gonna have to come in the next video. I was hoping to get the feet done in this video, and I'm not even started on those yet, but luckily I made a lot of progress on the electronics instead. So I think to wrap this video up, I wanna put that board inside R2, hook it up to the dome, and see if I can spin it around with a remote. Check this out. That is super cool. All right, I think that's a pretty good place to wrap up this video. Thank you so much for checking this out. And in the next one, we're gonna take some more leaps forward on R2-D2. If you wanna go back and see the previous videos on this, we've got a playlist with all of those. And we have tons of other types of projects of all different types if you wanna check out. Be sure to hit subscribe if you're not already. Thanks for watching. We'll see you next time. And also in the last video, we got the dome really far along, flong. This is a 12 volt motor, so I've got 12 volts going, 12 volts. Oh boy, so I've got 12 volts going, dang it, I did it again. 0, 0, 0, 0, 0, 0. Yeah, it's like pushing. Hey, I'm Bob at I Like to Make Stuff. Today, we're gonna get R2-D2 on his feet. We are back here on R2-D2. I'm excited because I'm just picking up where I left off in the last video that was just a couple of days ago for me. And in that video, we got a lot of the electronics done for R2. Obviously, his lights have been working for a while, but now I can actually control his head and he makes sounds. And that's all through this PlayStation 3 remote. If you missed that video, go back and check it out. But when I did all those electronics, I also got the feet motors hooked up, so that they actually work from the controls as well. They're just not on him because he doesn't have feet. So today, we're actually finally gonna get started on the feet so we can get him on the floor and roll him around. Just like everything else on R2-D2, the feet can be built out of whatever material you want. Plastic, metal, wood, doesn't really matter. There's a million ways to do it. I decided to use 1/8" aluminum. And one of the downsides of that is that a lot of the metal feet plans actually require you to bend 1/8 or 1/4" aluminum in certain ways that I don't really have a good way to do. Luckily, I found a flat pack version of the plans, and this is a DXF file that's all flat pieces that you can just cut out. If you want, you could print these out as a template, put it on your plastic or your metal or your wood, cut it by hand, or you can send this file to some software and cut it out on a CNC. I'm going to use my Wazer just so I can get a nice clean cut on the aluminum. The article on the Astromech forum also has a list of all the hardware you need, stuff from the hardware store and from Vex Robotics, specialty wheels, motors, chains, all that. I'll show you that in just a minute, but first, let's get this stuff cut out. After lots of cutting on the Wazer, I have all the panels that I need to put together. Now these are going to be sandwiched with some bolts and some aluminum spacers. If you actually wanted to do this, you're definitely going to have to read through all the instructions on the forum, so rather than me just going through those again here, you're just going to get to watch me put it together. I've got the basic parts of this put together. I just wanted to walk you through what's here, in case you're curious. You have a drive wheel on the back that has a sprocket. That's going to be chain driven to a motor that's going to go in here. Now this is a replacement scooter motor. It's nothing really powerful or special. And it goes in there and mounts, and it will drive this back wheel. The front wheel is actually really interesting. This is called an omni wheel, and it's often used in different robotics projects. And it rolls this way on the bearing, and then each one of these gray things is a separate wheel that rolls perpendicular to the main bearing. And so this thing can sit on a table and kind of move in every direction, which is why it's called an omni wheel. Okay, we got sound, so we should have drive, but we don't.
Why didn't it work?
It didn't work because all of the wires are hooked up except for the ones that actually go to the motors.
Mine is not connected to the brain.
I got the two outer feet put on, and I also made up the center foot. It's pretty similar, except that there's no drive wheel. This one is actually mounted to a little leg that gets attached to the bottom of it. So I'm temporarily drilling some holes so I can drive in some screws just to test fit the whole thing. When you make an R2, you find that a lot of times you have to put something together temporarily just to see if it works, and then you take it apart and figure out how to put it back together in a strong way so that it'll last. Sound, motion. It was super cool to get him on the ground and rolling around, but in that process I saw that the legs were not attached as strongly as they needed to be. So since then, I actually took the legs off, added in an aluminum plate here, and then reinforced where all the bolts that came through. So now the legs are far more sturdy. So when we put him back on the ground, he's gonna be a lot stronger. I did make a couple of other changes that I want to show you though. I added a fuse block here, just in case there are any problems, those fuses will blow and save the electronics. And based on the last video, I actually switched over from DeWalt to Milwaukee. And the reason I did that is because a lot of people mentioned that the battery management system is in the tool on DeWalt stuff, but it's in the battery on Milwaukee. So the advantage here is that if this goes under voltage, I don't have to worry about it damaging the cell inside the battery over time. I just 3D printed a housing to fit over the battery and put the wires directly into that. Next up, we need to move on to the rest of the feet. So these feet that we put together are obviously just the inside, and there's a whole shell that goes over top of this. I've got those pieces cut, so let me go show them to you. Whereas the inner part of the foot is all bolt together, the outer part is going to be welded together, which means I am in the very beginning process of learning how to TIG weld aluminum. I've got a long way to go on it, but I wanted to show you the pieces. These are pieces that I cut out on the Wazer, and they have little finger joint kind of areas built into them so that the pieces will fit together. Like this piece in the corner has the two parts that fit together, and they're tight enough that they will hold each other in place so that you can weld them together. So basically the entire foot is built out of this type of joint. You get it all held together, and then you go back and reinforce it with some welds. After a whole lot of welding, I'm at this point, and it's not completely done. There's a lot of gaps here, but a lot of those gaps will actually be filled with body filler. I'm gonna use some Bondo type material to fill in these spaces that are not structural. It is welded together, so it's nice and strong, and I don't have to fill in every little piece with aluminum. We're gonna do that later on, but the next step is actually figure out how to put this panel that's removable on this front face. You'll notice here that I cut a little section out of that, and that's because the bolt for the foot needs to go in here, and I need to be able to tighten it from the other side. So if this top section was in place, you couldn't get to the head of the bolt. The way around this is to actually take this panel and put the tab that I cut out of that frame on the top here, and this will give it an alignment so it can slide in there and snap into place. Then we'll use some magnets on the bottom. First step, let's get this fit and get this glued to this with some JB Weld. Now that we got that tab on there, the way this is going to attach is the tab will go up inside and then the bottom will snap into place. And the bottom is going to snap into place onto some magnets. But this entire thing is aluminum, so we can't use magnets directly on it. To get around that, we're actually going to take some JB Weld and put some small rare earth magnets on the inside of the panel. And then also with JB Weld, put in a steel rod that goes and lines up with those magnets, so the magnets will attach to the rod. I've got all three of the magnets here in little blobs of JB Weld, and I have to wait till that dries or cures or whatever it does, because otherwise they're gonna hop out and grab onto this steel rod. Once these are in place, I can actually put some JB Weld on the end of the rod, snap it onto the magnets, and it will hold in exactly the right position while it cures on the ends of this rod. This is actually the first of the 2 feet that I did, and this was mainly to experiment on. I wanted to make sure that I could figure out how to do the welding and everything off camera. But this system of locking this in with magnets works out really well. Once you get that hooked in there, it snaps right in place and it's nice and strong. He's on wheels, which means he's rolling around, he's got feet, he doesn't have to be on a stand or a table anymore. That's awesome, but obviously his ankles are kind of wobbly, he's got a really long way to go. We've got a bunch of other stuff. There's still pieces that are missing. None of these flaps work yet. He doesn't have a skirt on down here, which is a whole piece to kind of hide some of this. We still got a lot of work to do, but I think this is a great place to stop this particular video, because I'm pretty stoked that he's rolling around. Thanks for hanging out with me on this long-term project. We've got a lot more to do, but the next steps are gonna have to wait a little bit. We've got tons of other types of projects that you may wanna check out, and if you're not subscribed, be sure to do that as well. That's it for this one. Thanks for watching. We'll see you next time. Hey, I'm Bob, and I like to make stuff. Hey, I'm Bob, and I like... Dang it, what is wrong?
This is especially hard to
Hey, blah, blah.
action.
That was super cool. Thanks for hanging out. Oh, well. Ow. Hey, I'm Bob and I like to make stuff, and this is R2-D2. We are back here with R2-D2. I haven't touched this project in a very long time. A lot of people have been asking about it. We're finally gonna try to wrap it up in this video. Obviously, you're never really gonna finish R2-D2. There's always stuff you can add to it, more things that can move. So, in this video, what I wanna try to do is get him on his completed feet, rolling around, and have it aesthetically finished. So all the parts look right, and the head will spin around, and these top flaps will open and close. I want to stop there. And then getting all these other things to open and close, I'm going to do later on because it's the same project, it's the same work, just in different places. So today, the first thing we're going to do is work on the feet and try to get them finished up so he can be rolling around all the time. These are all three parts that actually act as the center foot. This thing is called the skirt, and it kind of surrounds the foot. Then the foot connects right here. And so I've got all these pieces made, but I got to put them all together. I've got to finish up some of the paint and stuff on the center foot. And I think I'm actually going to have to rebuild this center leg that mounts in there because it's got some cracks in it. I can just do a better job. So I'm going to rebuild this thing basically the same, then get this mounted with the skirt on the bottom side. And unfortunately, that means I have to take the entire R2 unit and flip it on its back somehow. So first thing we're going to do is finish rebuilding this, get this foot painted, and then we'll put it all together. In the last video, you saw me make the internal foot. This is the motorized part of the foot, and then this is the foot shell, and it goes on top of it. But what I've done since then is actually add this nice big curvy swoopy piece to this. Now this whole foot is aluminum except for this piece, and I did that out of a thin piece of styrene because I could form it. I could bend it really easily. I got it on here completely glued in place, and then I set it down over top of the foot and figured out where I need to cut away so that the motor has a place to go. Now, I've got this one worked up, and this is made so that this battery box, which is just a 3D printed box, can fit up in there to cover the internals of the foot. I've done this one, but I wanted to show you what I was doing because now I have to cut out the other side. Next up, I need to make some hoses, and these go on the feet connected to the battery boxes. Apparently, you used to be able to buy just plumbing hoses, and they were brass on the outside like this, but you can't just buy that from your local big box store anymore, that I can find anyway. So I had to get this stuff by the foot. It's oversized, unfortunately, which means I need to take the inner rubber hose out of this and put in a smaller rubber hose so that these things can fit inside these little adapters. Now these adapters stick into the feet, stick into the battery boxes. So I don't know if this is gonna work, honestly. I'm gonna have to take the brass off of here, put it onto here, and then cut it into 4 pieces. This is extremely weird, but I did figure it out. So with the sheathing, the outside off of it, it's loose and you can stretch it to make it thinner. It'll go over whatever size tube you put on the inside of it, which is good because that's what I was hoping. But then I realized that once I got the end on here and this fed through, there's no good way to cut it off where you need it and keep it tight. So I'm gonna take the tube out of this, cut that tube to length, and then cut pieces of this that are slightly longer so that I can kind of wrap it around and then feed it through these fixtures, and then I'll put some glue in here on the end just to kind of hold it all together. I think this is gonna work. So we're gonna go 2 inches in, just under 2 inches. That's not right at all. It's 13 and a half. Man, what's going on here? Yeah, it's 1 5/8. How much was it? 3 and what? But that's not right either. Is he changing shape? What's happening here? Something is wrong with me. This video is sponsored by everything in this box. This is full of I Like to Make Stuff merch, and I am terrible about telling all of you that we have merch for sale. If you go to shop.iliketomakestuff.com, we've got digital plans for a bunch of projects, or hats, like this one. We've got this hat, a bunch of other hats, and hoodies, and t-shirts, like this one, and this shirt, and this shirt, and this shirt, and I really like this shirt. We have all these designs in a whole bunch of different colors in men's and women's sizes, even in kids sizes, and they're a great way for you to show people that you like to make stuff as well. It's also an awesome way to support what we do here at I Like to Make Stuff, so be sure to head over to shop.iliketomakestuff.com. Thank you to me for sponsoring this video. I've been working on the electronics for R2-D2 and they're actually coming along. We're really far along at this point. We've got servos in the dome so that the panels can open and close. So let me show you what changes I've made to make that possible. Now we've got basically the same electronic setup that we had before down here. This is all going to go in the body. But now we've added a few more boards to the dome, and those control the sounds and these servos that open and close these. I'll show you that in a little bit, but they need to be tweaked to get them all in the right location. We can't do that until it's actually sitting on top of the droid. So the next big stage is to put all of this stuff in the body and then be able to mount the dome on top. But this is a really key piece to make that possible. This is called a slip ring, and basically you've got wires that come in the top, the same wires that come out the bottom, but this entire thing can freely rotate without twisting the wires up. So this has to be mounted kind of on top of the body so that the head can sit on top and these wires don't get twisted. I want to point out a couple other things. I've actually added another controller, so now there's one that's just for the feet and some sounds, and then the other one is for the dome and for some different sound effects and for the panels. And these controllers are old PlayStation 3 controllers. The first one I spent a lot of money on eBay, and then the other one I found at a used game store really cheap. So if you're going to get these, start there. Now I mentioned this before in a previous video, but the code that's running all of this is stuff that I did not write. It was done by some really smart people in the astromech world, and all of that stuff is freely available and it's really well documented. In fact, there are huge amounts of conversations about tweaking and getting exactly the right setup. Just so you know, in case you're interested, the thing that's running all of this is called Shadow, and it uses those PlayStation controllers. And then the stuff that I added to the dome, those boards are called Arduino boards. There's an addition to the code that runs this to integrate those Arduino boards. All of that stuff is on the Astromech forum, and if you're thinking about building a droid, that's absolutely where you need to start. So the next big effort is to take all of those electronics and stick them in the body. I made a piece that runs across here for the slip ring to mount, and so all the wires will basically be coming up through this hole. And I need to take all those electronics and put them on a different type of mounting board so that I can get them in here, mount them on the inside of the body, run the wires up to the slip ring, then we can connect the dome, drop it on place, and then start tweaking the position of all those servos to get them to open and close in the right way. So we've got the electronics just about ready to insert into the back of R2, but I'm also having to make a place to put a switch. He needs an overall power switch to turn it on and off. Unfortunately, I have to kind of put that on the bottom in a weird place so that it won't get hit by accident. So that means I need to cut a hole right here so that I can put the switch in from the bottom, and then the wires will come through here and connect to the electronics and to the battery, both of which will be on the inside. So I'm gonna have to cut this out right there. I think I'm actually gonna use this palm router because I can get it in here and do the majority of the cutting with that and then come back with the Dremel to kind of clean up the corners. Okay, so I've got new connectors on all these. This is the switch that's gonna go in from the bottom like I showed before. It will connect to the battery, and then the other side will connect to my new electronics block. And I've got everything kind of condensed down onto this block. It can go in through the opening in the back and then screw down to the bottom so it's nice and secure. I've got all the connection wires labeled here and kind of bundled so I can connect them up into the dome and everything else. So I think we can actually put his guts in for the first time. Now that I've got all of his guts on the inside, I've added these two panels. Now these are just lighted panels, they don't really do anything, except I added a USB port right here. And this is a little attachment I got off Amazon. It's a female to female USB kind of connector extender. And I'm gonna connect it on the inside to an Arduino that's running this whole thing. So if I need to reprogram him or make changes, I can just plug in right here, which I think will be kind of cool. Now I've also done some work on the dome. I've been kind of adjusting the servos for these panels to get them in the right position so that they work, made sure that the sounds and all the controls are working, and very soon, this is gonna go on for the final time. But first, I've got to finish up these arms and make a way for them to be held in place, and then fix a couple little details. Here's where we're at on these utility arms. It's kind of the final piece. I'm pretty excited to get these put together, but I did kind of have to work several different techniques into one little section. So I've got some 3D printed channels, and these are made from an entirely 3D printed droid. I just pulled out this piece, but luckily these fit perfectly behind these openings. So this also has a hole built into it to fit the hole on this, and you can see I've actually had some problems with the paint. It's beginning to fall apart in areas of wear. So there's a good chance that these arms are gonna have to get repainted eventually, but for now, we're gonna go ahead and mount these in here. And then to make sure that that can pivot correctly, I had to take a piece of aluminum, turn it on the lathe to a little shaft that's the right size for both of these pieces. So basically, I can kind of fit these together, put in that pin, and then once I've got this as a single assembly, now this piece can move freely, and there's even a spot in the back so that you can add a servo arm to go in. Now I'm not gonna do that yet, but one of these days I'll come back and add some servos so that these can open and close. But again, I'm gonna have to repaint these, I think, so I'm gonna wait on that work. Now the idea here is to take this entire assembly, glue it on the back side of this, and you'll notice that this end is still open. And that's because this other piece is gonna have to come on after the fact, get pushed into place and glued that way. If I tried to put this whole thing in at one time, it actually wouldn't fit from the inside. This is another example of me doing things in the wrong order. So the workaround is to put this in first and then glue this piece in. So here it is. I'm not really gonna say that he's finished because honestly, I think anybody that makes a droid like this will tell you that they're never finished. In fact, just the act of bringing it up here and rolling it around in this space showed me a bunch of things that are too loose, that need to be tightened up or reinforced. So I've already got a bunch more work to do. And eventually I'm gonna add servos to all these other doors, to these arms. I'll probably add some more sounds, some more lights, things like that, but those will all be in the future at some point. Be sure to check out our Instagram if you want to keep up with progress on this going forward. This will probably be the last video about R2 right here on the channel though. As you've watched these videos, I hope that seeing this thing come to life has given you some inspiration. Maybe there's something that you've always wanted to have, to see exist in the real world. You can do it. Just jump in, start learning as you go. And if you have something like that, I would love to hear about it down in the comments because you may find somebody else down there that's interested in the same thing. We've got tons of other types of projects that you may want to check out, and if you're not subscribed, be sure to do that as well. That's it for this one. Thanks for watching. We'll see you next time. Hey, I'm Bobby and I like to make stuff, and this is R2-D2. And this is R2-D2.